Hello, I'm Barry Matsumori, and I wanted to dive right into a very relevant discussion on what is affecting us all now and how advancements in communication technology that are already taking place help the near-term and long-term future. Let's talk about the factors that are affecting every one of us right now, and I believe no one disputes that COVID-19 has highly influenced our activities in the past half year, and that influence continues. So what are those factors and the tie into communications technology? Let's articulate this a bit. What's going to be influenced? How we travel, where we stay, if and when we travel, where and how we live, locally and away. What are the activities outside of the home now? Some of you don't even want to talk about the effect on your kids. But the biggest effect has been on how we interact with each other. Face-to-face meetings are now minimal or non-existent, and that's not changing much in the near future. So how do we communicate? Video conferencing is the means we have used to substitute for face-to-face interactions. But VC fatigue is clear, and not only is VC not fulfilling for effective interactions, but issues such as poor internet connections lead to much less satisfying experiences. How many of you have upgraded your home internet plans, or at least yearn to do so? Is this going to change in the longer term? Likely in all cases, face-to-face will be diminished at a minimum as organizations realize that those reduced meetings equal reductions in travel expenses and productivity gains due to less travel time expended. But if the way we interact has changed, what needs are there to grant a more engaging experience? Let's discuss the factors involved. Now that I've rushed into the context of today's discussion, let me thank you for your participation in this workshop and spending a few minutes with me today. We earlier discussed the changes in the way we interact with each other and its influence on communications. Let's spend more time delving into this. Again, I'm Barry Matsumori, the CEO of BridgeComm. A brief summary of my background is that I have worked in aerospace for SpaceX as well as the Virgin Group. I was responsible for business development at SpaceX for Elon. However, most of my career was at Qualcomm as an early employee working development as well as managing product lines. And just a very quick background on BridgeComm. We are a US company based in Denver, Colorado. Our focus is only on optical wireless communications for all environments and have worked starting in space with both commercial and US government programs. BridgeComm has developed some unique capabilities, and we will discuss this more later. Let's go back to the modern situation we all see ourselves in and focus on the communications related aspects. There are several traits that we all have seen, but it's good to articulate them. We all know we are doing significantly diminished face-to-face meetings, and although this will improve, there are going to be some lasting effects. Small things that provide face-to-face feedback, like shaking hands, just isn't done as much anymore. No matter what, the trend for data consumption continues to increase, and the difference is the number of accounts per user, because some of those data accounts are machines related to humans. We are all doing video conferencing, but there are a number of programs looking at richer interactions. Some are using virtual reality and augmented reality, and others look to get more sensor data. The same trend of increased data needs exists. You have all been exposed to 5G to some extent, and the broad range of promised services will increase data usage relative to past consumption. The one we all want is timeliness of data we search for. Humans can detect 20 milliseconds of delay, so not that we have to deliver that rate, but expectations continue to grow. Finally, security is an interesting value. When security is violated, it's perceived as extremely valuable, but until then, the value may not be seen as high. But as our dependency on communication systems increases, this trait becomes even more valued. All the needs described in the last slide for a communication system will translate into requirements for a product. It's clear that capacity growth will never cease, and communication systems need to be able to accommodate not only the near term, but longer term future. But capacity isn't enough. If a large number of users are connected, but they have inferior speed, they will not be happy. Just as a reference, 5G specifies a maximum rate of 10 gigabits per second, so that sets the lower bounds of what is expected. Therefore, speeds in the realm of tens of gigabits per second need to be considered with really the thought of 100 plus gigabits per second. As mentioned earlier, increased security for remote communications is continued to be needed, and multiple layers of security is a key technique to be able to bolster security. Communication systems evolve, but it's expected that these systems are smaller, lighter, more efficient, and cheaper than the systems they surpassed. It's also true in all electronics. Lastly, all of these needs apply to all markets. It doesn't matter if the US government is the customer or it's commercial. So great, we now understand what is needed in product requirements, but matching to what is possible is going to be the challenge. Let's talk about that. So far, I have been leading you down a path of breadcrumbs, and hopefully I've kept you engaged on where we're going. There are options for overcoming the challenges that have arisen. RF is a very well known and understood technology. It's the basis of all wireless communications for the most part. It's a great technology that has had a myriad of innovations applied to derive performance, capacity, and security, but it's also beginning to see the compromises in what can be seen in next generations as the spectrum goes higher. I don't think this discussion is about replacing RF, but rather what is possible to augment RF systems such that the best possible capability is realized to service the applications that have needs beyond what can be done in the RF domain. Optical wireless communications has been around for a while, and point-to-point links are fairly well understood. Some of the characteristics of OWC make it desirable. Very fast speeds at 10 plus gigabits per second. Lots of capacity, as there is no inherent interference given the highly directional nature. Very secure links, as the beams are narrow and only go to the intended receiver. But traditionally, these are point-to-point systems. In order to really augment an RF system, point-to-multi-point capabilities required. So now we consider an advanced optical wireless communication system that can support the notion of point-to-multipoint communications. Doing so will offer the benefits of OWC, yet support the desirable traits of RF. Certainly, others have studied this capability in the past. BridgeComm has developed this technology that we call MoCA, which stands for Managed Optical Communications Array. The MoCA technology will enable those multiple simultaneous links and mobility coverage that RF also supports. Let me articulate this a bit more. I think everyone recognizes how RF and traditional laser communications will work, as illustrated in the left-hand box. To reiterate, one of the key capabilities of RF is providing coverage of multiple simultaneous terminals. So one could look for a solution in the OWC domain, but traditionally these were point-to-point only. While such a solution is able to address some of the issues cited earlier, it lacked the one trait that RF brings to communication systems, and that is the ability to engage multiple parties. What BridgeComm has done is design, develop, and now tested a laser-based point-to-multipoint solution that addresses the challenges in various domains, yet bridges the gap of engaging multiple clients. This capability is based on the MoCA technology. What does this capability interpret itself with respect to the needs described in the prior discussion? Let's see. Of course, high throughput is expected, so tens of gigabits. And likewise, the communication links are secure. A multi-user system has to scale to a large number of users. Otherwise, it won't be useful for a broad set of applications. But in order to scale, a system must have attributes such as non-mechanical steering, as gimbals can't be part of a system that scales. Further, the bandwidth allocated to all users covered needs to be dynamic to address the changing needs of individual users. An inherent part of this is being able to not only vary the data rate per beam, but also consolidate beams such that very large rates for a given set of users can be supported. Mesh networking is a key concept for scaling a complex communication systems, and MoCA technology will support mesh networks. As mentioned before, all the factors for advancing systems need to be more efficient, improve swap, and lower cost. Those are expected. Finally, the support of all domains and environments has to be provided, and MoCA technology took this into account in its base design approach. So it has been great to not only design the MoCA technology-based system, but BridgeComm had to go a step further and demonstrate the capabilities above and then some. So we have done this and have verified the system's capabilities. As you can imagine, accomplishing development work in the middle of COVID-19 has been taxing, but we have managed through challenges here with safe practices in the lab. We demonstrated a broad set of capabilities and cited some functions mentioned in the slide. We had a configuration that had multiple transmitters and receivers that showed the combination of either combining or splitting beams. Further, we were steering beams to either connect with alternate transmitters or receivers, as well as demonstrating tracking. Again, not all the functions are cited. I won't go into the details of the long demonstration here, but it's worth mentioning that the session was independently reviewed and evaluated. It was considered very successful, and BridgeComm is moving on to the next stage of product development. We are now in the process of creating a module of an array size that can be used as the basis for a broad set of applications. As you can see, MoCA technology has demonstrated a versatility in communications that's not been realized to date. But what does this mean for product applications? Overall, this means having assured, high bandwidth secure communications that covers the multitude of terminals across multiple domains, and having the ability to dynamically and flexibly adjust bandwidth and data routing on the fly in response to the changing environments. All of these are critical capabilities. The modular design allows for multiple end-user terminal options, enabling BridgeComm to develop interoperable, low-cost, low-swap user terminals for space, airborne, ground, and maritime applications. Thanks to MoCA technology, BridgeComm is able to build a comprehensive product portfolio which enables secure communications in every domain. Getting back to how we started this discussion, COVID-19 has had many changes in the way we live, work, and interact. Some of the changes are temporary, but some are going to be longer lasting, and how we interact is going to be one of these bigger changes. Communications technologies will improve our interactions by providing richer experiences. That will drive the need for further advances in capabilities. BridgeComm sees MoCA technology driving products that will support the broader capabilities needed in overall communications. We have seen an all-time high in the interest level for optical comms and have been busy supporting various initiatives. MoCA technology-based products will be a game changer that realizes capabilities such as mesh networking in the optical domain. We know RF is not going away and is very useful, but that technology needs to be augmented given the constraints that now exist with an innovative, complementary solution that BridgeComm can provide. Thank you again for spending time with me today to learn about a demonstrated approach to supporting the future of communications. We would love to spend more time talking about this, and please feel free to contact me for more information. Have a great workshop. Thanks.